Hi everybody, welcome back to the Feynman Technique. This is my fourth video in the series Things We Take for Granted. And the thing that we are taking for granted today is the Pythagorean Theorem. And it says this, that a squared plus b squared is equal to c squared for any right triangle like this, that's labeled A, B, and C, where that's a right angle. Everybody knows that. You guys are all familiar with that, but I bet less of you are familiar with where it comes from. So I'm going to show that today. So this is what I call the little square in big square method. And how it's set up is you just make a big square and you put a little square inside of it. And you rotate that square, the little square, until the points of the little square intersect with the sides of the big square. Now, there are obviously restrictions on the size of these squares, namely, the little square has to be less than the area of the big square and also greater than 1/2 of the area of the big square. And I'll leave that second part of that restriction, the part where this one has to be greater than half the area of this, as kind of an exercise for you guys to figure out if you don't know already why that has to be true. But that does have to be true. But anyway, let's get going. So how are we going to get a squared plus b squared equals c squared from this? Well, you'll notice I labeled this part right here from this line right here, A, and this line right here, B. And you'll notice that if this is A, this is also going to be A. So is this, and so is this. And if this is B, then this is going to be B, that's going to be B, and that's going to be B as well. It should be pretty obvious that these triangles are going to be the same triangle, just rotated by 90 degrees over and over again. So the first thing that we want to realize is that the area of this big square can be represented two different ways. We can simply square one of these sides to get the area of the big square, or we can add up the area of the little square plus the area of the four triangles. So let's express it as the square of a side. So the area of the big square is going to be equal to, I'll write that down, the area of the big square can be written like this. We can call it, just its side squared. Well, what is its side? Its side is equal to A plus B. So we take A plus B and we square it. Well, there's another way we could express the area of this big square. We could call it the area of this square, the little one, plus the area of the four triangles. All right. Well, what is, according to this diagram, the area of the little square? It is c squared. Well, what's the area of one of the little triangles? Well, we know that the area of a triangle is 1/2 length times height, or length times width, whatever. In this case, it's going to be 1/2 A times this side, which is B. 1/2 A times B, but we have 4 of them, so it's really 2AB. All right, so the area of the big square is equal to either A plus B all squared, or it's equal to C squared plus 2AB. And both those things will add up to the exact same area, so they're equal to each other. All right, let's FOIL this out. Foiling that out, and we get A squared plus 2AB plus B squared is equal to C squared plus 2AB, right? this is equal to this is equal to this. Well, this is equal to this, so this is equal to this. Let's subtract 2ab from both sides. That goes away, and we're left with simply a squared plus b squared is equal to c squared, which means that this length squared plus this length squared is equal to this length squared. And that's where the Pythagorean theorem comes from. A lot of you probably already knew that. Maybe some of you hadn't seen this particular proof of it, but this is actually the proof that got me interested in mathematics. I was just, going through YouTube one day, and this proof of it came up. And ever since I watched that proof and understood it fairly easily, this is a fairly easy proof. Ever since then, I was kind of hooked on math, and that's what started my journey about, gosh, it's been about 7 years ago is when I started studying math, and it was because of this. But anyway, that's it. The Pythagorean theorem proved. Hope you enjoyed that.